So now we'll move on to our next speaker. I would like to invite Michael Anthony. He's a co-founder and director of Vertify.earth that delivers nature audits based on satellite data. He works with organizations across various sectors to monitor risk and tailor-make climate solutions that are actionable and accountable. So please give it up for Michael.
Thank you, Sarah. Thank you. Thank you, Sarah. Thanks to the AIES team. It's amazing to see how you're growing. I think quite in line with I think what this campus and Innovationspark is growing. You might have noticed that I'm here we go. Michael Anthony, that I'm lacking these little acronyms that most of you have in front of your name. And those who don't have it yet, I think you're right on your way to get one of those soon. I don't, but I'll try to make up with offering you some examples and some insights more in terms of into the banalities of AI in action, things that we observed over the last couple of years in our work at Vertify.earth, where we work with the development sector, a lot with the media or for the media, and where we sort of make different observations, mostly in our work, both here in Europe, but also in South Asia, where we sort of have our second hub. And hence, what I'd like to share with you are not as much insights, or as much insights as about AI in action, but also about AI and its hidden blind spots. And mainly really about the relevance of ground data and context that is eventually driving good results of AI and environment. And the two examples I would refer to are, one is from India's forests, where we've been struggling with global models and local realities. And the other example is in working in urban environment, measuring urban green based on satellite data. And I should say that most of the work that we're doing is based on satellite data as the primary source, sort of as a first level nature audit, and then others or our clients or our users would build on it in drawing on different more ground-based data sets. Onto the first case of India. So we've been working with the government of Goa recently, and the government of Goa had a host of questions for us, where they were looking for some support in different types of environmental modeling and measurements. And one of those questions was around the forest system in Goa and an understanding of what is the carbon sequestration potential of Indian forests. Of Goan forests. And our first go-to source, we thought of this being a straightforward task, was to look into the JEDI dataset. JEDI is a NASA satellite that those of you would be very familiar that are working with geospatial data. JEDI is a stationary satellite that takes LiDAR measurement of tree canopy height. And there is a derivative of that product is a model that derives forest biomass, or generally above ground biomass, based on those LiDAR measurements. It's an excellent data product, and also the underlying or the forest biomass product is an excellent data product. But it has one caveat when we applied it in that particular Indian context, is that the results seemed off the mark. And the reason is that the JEDI biomass product has been calibrated with data sets from North and South America. And there's an obvious blind spot for South Asia. There are some data points from different European sites and from some sites in Africa, but clearly a blind spot on South Asia. And that's also something that we realized when we were running the JEDI product over those Indian geographies, mostly in Goa, and then we had another project in the Himalayas. So we had to shift course, and the course shift was that we became aware of sort of a bit of a data treasure of LiDAR-based, airborne LiDAR-based data that was taken in different geographies in South Asia to exactly address that data gap that I showed on the first image. It was that group of researchers that also had their article published in Nature. And they were taking ground samples on different sites in South Asia, and one of them also next to our geography in Goa, in the neighboring state of Karnataka. So we took that data set and then combined it with Sentinel imagery, then chipped the landscapes into 5,000 patches, developed a deep learning model around it, and eventually were able to deliver much more robust results than this one was the JEDI-based forest biomass estimations, and this was the deep learning model that we applied. And on the left is the coast, and on the right is the inland. And as you can see, the deep learning model that we applied based on ground data from a neighboring geography obviously brought us back much better data sets, much better results. And that's really because of the ground truth data. Now, not always do we get ground truth data as well packaged and as well prepared as those scientists took it for and later published in Nature. Very often we have to go and collect our ground truth data ourselves or work with partners to collect our ground truth data. And that's when we sort of run into those tricky cases, the messy realities on the ground. This was an example in the Himalayas, where we collected ground data on different tree species, and which obviously should have been sparsely distributed in the different ecosystems, but eventually they were all just indicating a location in the garden of near the garden or in the house of the researchers, and that was because that's where the apps got synced, or where some of these GPS data points were later added. Of course, there are ways around it. There are a number of great apps. There's Google Ground that was recently published, which you also introduced or recommended to the data enumerators. But then the head of the group was already having an iPhone, so he didn't want Google Ground to be used. He didn't want Google Ground to be used because obviously that's a tool that doesn't work on iPhone. Another case, another example I can refer to was our work on soil, working on soil organic carbon with geospatial data. Of course, that also requires a number of ground data inputs. We did some soil sampling. Here is an example of partners taking those soil samples in northern India. And then it took a couple of weeks to post them to the lab because the lab was somewhere else. There was a train travel involved that took 2 weeks. The lab was then closed, and it was all taking part in the pandemic. That closure sort of went on due to the pandemic. So eventually, until the data was being analyzed, was 2.5 months after data collection, and that was not in line with the protocol. So all that just to say, you're all aware of garbage in, garbage out. I don't have to explain you. Many of you had experiences, at least here in the Ecovision Lab, on the relevance and the challenges of collecting data. But it's just to remind us that in environmental AI, the input we're getting is not algorithms. The input is ground data. And that's determined by logistics, by people, by time, and that's one of the reasons why it is being so difficult. Now, it's not just ground data that determines the validity of insights. It's contextual understanding, obviously, that is as crucial, and that's true in fragile economies, as shown earlier, but it's also true in data-rich cities like this one in Hamburg, northern Germany, where we worked with high-resolution aerial imagery to classify urban versus green sealed surfaces, a classical task in environmental planning, urban planning, but also a classical task in remote sensing. We annotated hundreds of images, built a classification model that performed well, until we compared it with another year, 21 and 23. The model has told us there was a large increase in green cover. Anyone familiar with Hamburg, I happen to be familiar because I was born in Hamburg, could tell you there was not an increase in green cover. And you obviously guess it, what happened. The images on the left were taken in February, low sun, bare trees, very long shadows, and the 23 images were taken in July or somewhat in early spring, sort of early summer, with lush and green light. So again, this is just an image for illustration, just because I love it. We have to stay vigilant about the thresholds that we're using. The challenge is not what AI can see, but how we choose to use it. Simply because AI can see patterns, but it doesn't know what they mean. That's referring to my example in Hamburg. And global models look impressive, but they often encode somebody else's ecology. That refers to my example in India and the limitations of the JEDI data set. And really the bottom line is that environmental AI is only as just as the data and governance it builds on. And if there's really anything I want you to take away with from my talk is that if there's no context, there's no truth. Thanks.